And then I'll just welcome everybody to the October session of Lunch and Learn. Today we are pleased to have Matthew Dondenville here from Michael Baker International and DataMark to talk to us about indoor mapping. And I will turn the presentation over to Matthew, and you can run it however you like, Matthew. You can take questions interim or wait until the end, however you'd like.
Probably at the end, but we'll make sure we save plenty of time and we can go back. Just because I'm on a single screen, so it's hard to watch.
Sounds great.
Alrighty, I appreciate it. So my name, like you said, is Matt Dondenville. I lead our indoor mapping solutions at DataMark, and have been in the role about a year now. I actually came from Esri, and at Esri I led the, I was on the data science team, did a bunch with the 3D Technical Center, really pushing the bounds of use of geospatial, indoors, LiDAR, photogrammetry, a whole lot of different kinds of projects. And I came over, I wanted to really focus on scaling indoors, focus on how to collect efficiently, and then put it to a really good use case. And that's getting indoor mapping into the hands of the PSAPs and first responders in the field. So police, fire, EMS, SWAT, emergency managers. And so that's what I've been doing over the last year, working on products and then services that include data collection. And I wanted to share some of that today. When I started getting into public safety GIS, or public safety indoor mapping specifically, we remember last football season, the football story of Damar Hamlin and having a cardiac arrest on the field. And we're not all multi-million-dollar football players, so we all don't have our personal doctor standing by us with an AED. But it really hit home with when the idea of when you call in to a call taker, having that kind of indoor mapping data and those kind of assets to be able to have the person responding and calling 911 or someone next to get directions to a critical asset like an AED. Usually I talk in conference rooms about this, and conference rooms are historic for people going in. They obviously don't live there. So I ask them, what's the name of the conference room? And usually people don't know. And then where's the closest AED? And again, people don't know. So this is a good highlight. I mean, AEDs, fire extinguishers, mass bleed kits. These are all things that would be really helpful and paints a really good picture. On the dispatch side, the same thing, and we'll look at some of that today. Knowing where those assets are, but also knowing things that can lead to faster response through better routing, and even beyond floor plans like imagery, CCTV cameras, and additional data. So why indoor mapping? In the geospatial world, we've mapped most of the places on Earth, besides the ocean. That's a different story. So indoor mapping is not technically new. If you think of people building houses, they've been drawing maps of indoors and blueprints for hundreds of years. What is new about indoor mapping is the scalability and the way to disseminate it. That's really easy to do and makes it really easy to get into the hands of the people that need it. Specifically non-GIS stakeholders. So, like I said, there's millions of buildings in the US. And so one of the things that I really focus on is the data collection part and how to do it at scale. I wanted to set that specifically my background. I will admit that I did not come from public safety, but I've been learning public safety for a few years now, And every time I get to talk to people, I learn more. I really enjoy it. But I've done projects inside of all these different spaces for indoor mapping. And there's really, really strong use cases beyond public safety. And that's important to know because we'll talk about here about some of the funding and some of the aggregation of data and kind of highlighting that as a public safety professional, you're not the ones that own the buildings. And so management of that kind of data gets a little tricky. And so we talk about dual uses. So for example, a college campus or a K through 12 school district, they want to be mapped. They want their indoor maps and their school layouts in the hands of public safety professionals. But they also like to use that data for things like wayfinding. They want to use it for asset management of their buildings. And so there's multiple people using the same data set. We're using it for public safety, but there's also different stakeholders that have a really big interest in the initial mapping and then disseminating it in different ways. Specifically for public safety, we're just getting into this space. We know that most of the floor plans that we see are not accurate. I know talking to someone from a large municipality in Pennsylvania, they still use milk crates. So they find a milk crate full of blueprints for a block when they go out to respond to a fire or an incident. Then they go through those milk crates, and the paper plans in there are very outdated. They're stained. Only one person can read them at a time. It's just inefficient and really not the way of the future. The key of public safety is really the efficiency and the scalability of that indoor data. In a school setting, having things like who's the current teacher in that room, or data maintenance practices that when a school has a renovation or changes a room number, in the past, they've never had a strong obligation or law to tell the police, tell the fire, get that information out to everyone. They work on their own business plan, and that information is often not shared out. So indoor mapping can facilitate that and really make a good foundation of data that everyone can end up using. We have a really good use case in Maryland, a client that we've worked with for years in different product forms, but really took the swing with indoor mapping and used it in really a great way. And this county in Maryland is really good because it's not the biggest. We know that the PSAPs and the EOCs and larger jurisdictions obviously have more money to do the cool stuff first. But this jurisdiction in Maryland is a smaller county, but they're putting in buildings and collecting buildings at an astounding rate. And it's not limited to schools. It's all different kinds of buildings. And they're putting it in and then consuming it in their CAD and call handling that they're used to. And so very important thing is having a workflow that gets this indoor mapping data and information into something that your call takers, your dispatchers, your field personnel are used to. And so it's just a really good use case. They utilize different collection techniques, and I'll get into that a little bit. Something that we call public safety grade versus engineering grade, which is the quality of the data, and not necessarily that public safety grade is the worst quality. It just has a different use case. And by that, I mean, engineering grade, and if there's a facilities person that maybe I'm jumping ahead a little bit, but in a school district use case, maybe there's a few schools that have big projects coming up and they want to collect at a higher level of detail, obviously adding to the cost, but they can use that for a secondary use case of asset management. And then we call what we call public safety grade, which is not necessarily bad quality, it's just the design to scale. And we have a use case actually from this jurisdiction that I'll highlight a few times, that we actually went and did a high school, and it took 3.5 hours to do 300,000 square feet. And so that public safety grade is rapid. It's quick dissemination. Instead of millimeter accuracy LiDAR for engineering, the walls might be a centimeter off or 2 centimeters off. It's not like it's really bad data. It just doesn't need to be quite as accurate, because for public safety, our indoor mapping is, we want to know when things change as soon as possible and get things mapped in rapidly. So in public safety specifically, I've mentioned this a little bit so far, but we do have different stakeholders. Fire departments, obvious use cases just with the data alone, but the ability to do things like pre-planning on top of indoor mapping. And indoor mapping is evolving into technologies that are starting to present as GPS denied accuracy gets better. Motorola radios and radios now, a lot of them use GPS. When we go inside of a building, you don't really have GPS. And so the technology is starting to get there where we can start seeing movement inside. And so tracking that over a GIS or an indoor data set is something that can benefit the fire and police. Police, like I said, in the future tracking right now, things like routing, things like knowing where assets are, where's the electrical shut off, where's the water pump. It's really backed by a true GIS. So even in looping in things like inspection dates or water flow pressure or your hydrants layer from your local municipality. PSAPs, right at the beginning, I went through the use cases for PSAPs. You got the call takers that need that initial view and to be able to see some of those assets, locate the person calling as quickly as possible, and then dispatchers first off that location, and then some supplemental information. Being able to see things like CCTV cameras can be useful. The kind of the indoor street view of what's going on inside of a building, and then real-time feeds. So things like alarms, any of that information that can help them dispatch better and feedback information to a responding officer. Emergency directors, and this even goes into the idea of insurance. Indoor mapping really makes a digital twin. And digital twins is a very loose definition, but they can be different accuracies. So really at its core, it's making a recording of what that facility is. And that can be used for insurance purposes. It can be used for disaster response, disaster preparedness, a lot of different use cases. And then the fifth one, campus safety and security. This goes back to kind of the dual use of data, getting it to the PSAPs and the fire and police and dispatchers and call takers are all important, but it also helps local school district security, security planning, maybe campus security on a corporate campus or on a university. So there's a lot of great use cases and stakeholders. I wanted to switch over now to kind of where does this data come from? I said at the beginning that the data that everyone I'm talking to today, besides probably your own home, you're not the building owners. And it's hard to maintain something that you're not actively involved in. Maintain data for something that you have to go inside and see. And the whole reason that we need indoor mapping for public safety is because we're not in those buildings every day. And so to be expected to maintain that and to know when things change is really a hard use case. And so that comes down to initial collection and partnerships, and then maintenance strategies. We go down the maintenance strategy a lot of enabling the end user. And so giving a really stripped down but meaningful view to someone like a school administrator. They know that building. They can update the teachers' names for that classroom every year. If something changes, if there's an addition, they can communicate that back, and all those changes are then captured and then sent to the people that need it. And so when we look at the sources of input data, there's really a broad range. There's BIM and CAD is in drafting data. And those are really historically engineering. When a building is built or renovated, that's a new building. Sometimes those data sets are better, but a lot of times, if those data sets are older, renovations have been done since, maybe they didn't capture the assets, things like fire extinguishers or AEDs in there. Maybe they printed out the CAD to a PDF and it's just not good quality anymore. So we'll talk about some of those. Paper blueprints and is kind of what I said there when you go from CAD to PDF, and how we can convert those. Principles maps they can be really anything from a hand drawing, someone printing out a picture of aerial imagery and drawing over it. I've seen simple arrows to like how to get to a gym. And those are all technically starting points of indoor mapping data. But I'll talk about the pros and cons. And then what happens if we have nothing. So BIM, like I said, it's kind of the modern format of engineering, becoming more and more popular every day. And it's really good to get rich 3D information into indoor mapping data. It's very data rich. And so depending on the use case, for quick response, quick dissemination, sometimes we actually have to tone it down. But it's a great starting data set. And because it's one of the more modern formats, a lot of times it's for newer buildings, which means not as much has changed. CAD data, drafting data, it can be good or bad. It can be digitized over, it can be extracted out through tools and processes and conversions. And then there's some AI ML that can be used to extract things. But CAD is getting to be, CAD's been around for a little while now. And so we often run into CAD data sets that are older, things have changed, walls have moved. The attribution in the building is no longer relevant. And so we look at these, sometimes good, sometimes bad. Sometimes they convert really well and give us a good foundation to start and then go in and know that we have to go QA it. And then sometimes every once in a while we get in there and we're like, so much stuff has changed that it really makes sense to start from scratch. Paper blueprints, like I said, this is often engineering drawings or scans that have been scanned and now are like PDFs. You lose some of the quality and the resolution. And again, like CAD, through AI and ML, we can convert those in. We can digitize over them, but you still run into the same problems that sometimes the attribution is not there, the quality is not there. And then we have the principal map. I think this illustration really looks at it well. It's really just a paper napkin sketch. It gives a rough outline, and to be honest, in some use cases, this could serve a perfectly fine use case. If you need to just know, all right, what side of the building is the gym on, or if it's not a very complex building. So they all have their pros and cons. Obviously, the more detail, the more time. But what we really wanted to do, and one of my passions is, or one of the things that I really believe in life is using technology to make things efficient. And so I know of all these formats, I've converted to all these formats, but I really wanted to focus time on how to collect at scale. And so where do we start when we have nothing? Or where do we start when our input data sources are not what we really want them to be? There's a lot of options. Everything from manual data collection to really advanced SLAM LiDAR. And SLAM LiDAR, we are inside of a 4,000 person engineering firm. And so the engineering firm uses a lot of SLAM LiDAR for indoor mapping to get really, really crisp, high resolution measurements in indoor mapping. So we really have two sides of what we could do. Something as manual as hand data collection that drives us to indoor mapping data, and then SLAM LiDAR that also delivers indoor mapping data. But there's a lot of space in between, and there's a lot of pros and cons of each. Cost and scalability are two of those big ones. So we've done a lot of research and development and put a lot of time into kind of finding that happy medium between collecting fast and at scale with getting a good quality. We actually use a 360-degree camera, just a really simple camera. And the reason that we do this is low equipment cost. Being able to go into a building just with a camera in your pocket, really, and be able to derive both the blueprints, but also a lot of other really rich data for public safety. And I'll show that here in a second. Using AI and ML tools to derive those photos into the blueprints and to really work towards an automated process to reiterate that need for scalability in public safety. So like we said here, it's the initial product. The initial thing that we're talking about is those blueprints. But then depending on your capture method, and this is a pro of recapture versus conversion, you get all these, you can get all this other data. So we look here in this video playing, that was playing in the upper corner, and I can go back and replay it here. But something like this imagery from the 360 camera. When we look at the room up here, it's really just a rectangle room. But when you look at when you click anywhere within the floor plan, you can pull up the image that sees that area the best. And so that gives us different situational awareness inside of a building. We show an example of that a lot in like a band room. And a band room is really a square room. But when you click on it, you see that there's full height cabinets in the back that in an unfortunate situation, people could hide in, or someone you're looking for could hide in. In a cafeteria, again, really just 4 square walls, but there's all the lunch lady carts that people could hide in. Really gives a view of what's going on inside of the building. And that's enabled by the data collection. Other things beyond the floor plans that we're really seeing are bringing in the cameras, giving that real-time situational awareness, being able to see that. And while CCTV cameras are not necessarily a new technology, linking those up agnostically and putting them on a map, and specifically a floor aware map. So you have 3 CCTV cameras that are all stacked on top of each other. If you see them all without floor awareness or filtering per floor, but in an emergency, if it's on the 3rd floor, you really only want to click and see that camera on the 3rd floor. And I always reference it to, I think, Batman, where they have the citywide CCTV cameras and there's thousands of square boxes up on a screen. How do you know where hallway 1 is? If you're not the one that owns that CCTV camera or is in that building every day, you want to be able to see the one by the incident the quickest. And then other things, really, this is the foundation of the future for public safety. So things like pre-planning, things like real-time data of locations. So incident debrief, but also real-time incident management. This is all, it all needs that initial indoor mapping data to be built upon. And then where we get to, and I mentioned this at the beginning with our Maryland example, is consuming data. The real estate on a screen for emergency response is already so flooded. There's so many maps, there's so many mapping applications. And so really getting your indoor mapping into something that's already out there, integrating, having your data collection, but then the middleware to kind of feed into different data sets. And by doing this right, you get the benefits of things like the CCTV, the 360 cameras, the floor awareness. And then through that pipeline, you're always getting things like the real-time updates. So as soon as a teacher or a school principal changes what teachers in a room, or maybe there's a renovation at the local apartment complex and they change what room is what, that data, without even thinking about it, gets updated into the software products that you use every single day. And then you don't have to worry about a separate sign-on in the case of emergency, trying to see this data quickly and fast, and not needing to sign on to and dig through and find more passwords is always a benefit. So I wanted to kind of finish up here before questions with some considerations and takeaways. I mentioned the public safety grade versus engineering grade, and really per use case, there's no right answer. Some buildings, like I said, the dual use is that facilities wants it for an engineering project in the future too. Maybe they're going to chip in money. Maybe they're willing to pay for it. I've seen all these different use cases, and it determines what accuracy of data you need. Obviously, the more data, the longer it takes to derive a product. But there's different uses of that data. And then really knowing and solidifying that partnership. Planning for the future. Everything I do is about scalability. I want to find options for everyone's use case. That Maryland example was, it had, I think we converted from 4 different types of products, and we collected in 2 different ways. We also added things like drone data and other outlying data to build that solution. And so one jurisdiction can utilize many different kinds of conversion and collection and aggregate that all together and spit it out in the same format into your CAD and call handling. Really, this is kind of an infancy of a technology in the public safety market. And so asking the right questions, working with vendors to get data into the formats into your existing products and driving different use cases. We're just starting to think about all the different use cases, and hearing about them and talking to people is how I learn. Standards. If we truly go down this public safety grade, engineering grade, and even between engineering grade, everything we do needs to be about documentation. So if you collect one school with LiDAR, it's a super accurate map. It's really helpful to know that 5 years down the line, versus something you just digitize that in GIS data, it could look very similar. But one you might be able to use for a different use case down the line. And so knowing that, creating internal standards, the industry is looking at industry-wide standards, and it's being talked about. And there are some guides. And so our guides come from the GIS community starting to, BIM and CAD historically have some, and then ISO 19650 is a BIM standard that also translates really well to storage of this kind of data. Again, with the scalability, I really pound that. It doesn't really make sense to spend 9 months on one building or even a couple months on one building when there's so many buildings that we need to collect, so many school buildings. Don't repeat the data and aggregate. That really comes down to talking to the community. There's a lot of universities out there that have already started indoor mapping journeys. There's a lot of schools that have started indoor mapping journeys. They use them for different use cases, and they might already have the data. PDF data, there's that data out there too, and that can be used and aggregated as well. It's aggregating. It's just working with people that already have data to say, hey, we have a different use case to serve and protect, and we want to aggregate that and push it into our systems. Giving the building owner the power to make changes. This is where having tools to allow people like administrators the ability to update, trying to take that responsibility away from public safety professionals, because they're not in the buildings every day. They don't know exactly when changes come. And then really about the scalability, that sense of improvement. And so 300,000 square feet in less than 4 hours, and using things like consumer off-the-shelf products, and then backing it with technology, AI, to drive products at speed, is the way that the profession is going to be able to collect more, collect faster, and really get more data into public safety's hands. Again, this is the multi-agency portal is really about that partnership. If it's public, the EOC with the hospital, or with the school district, or public-private with the apartment building. These are all conversations to be able to collect, to be able to maintain data, to basically serve those institutions better, and is all important. And a lot of times we find that dual use of data that really strengthens that vested interest to participate. And then kind of the final recommendations is to find a partner that will teach you, to work with you. It goes back to this being a newer trend in area in public safety. It's not going away. It's only going to get more robust, and it's a journey. It's not like you can fly a satellite over and get a whole jurisdiction's data in one day. It's really a journey, different ideas of what buildings to collect first, how to collect them, help with those different partnerships, MOUs with different jurisdictions to be able to collect at scale and get this into your vendor's products. And then I think the last thing I wanted to say is, push back on vendors. Work with them. Make sure that the data that you're collecting can be used in different applications. So if you have data for a school and then in a couple of years the school wants to improve their own on-site security, or if they want to do asset management, these interoperable formats, it should be that different people can collect and put it into different vendors' software. And so that's kind of a challenge to keep on pushing for the industry. So I wanted to open it up to questions now, anything that you guys have. And then this is my contact information. If you guys have any questions going forward, I'd love talking about the space. Like I said, I've done a lot in the public safety now, but historically I've done projects with hospitals and corporate campuses and oil and gas and manufacturing and really all kinds of different indoor mapping type projects that I love talking about those use cases.
Thank you, Matthew. Does anyone have any questions?
Let me stop sharing and see if there's anything in the chat here too.
Well, while they're thinking about it, I have a question. Have you seen any examples of public-private partnerships with regards to funding? And for example, have you seen any examples of where a school district might partner with an emergency management or a PSAP to fund this type of project because of the mutual benefits?
Jennifer, you were on mute there.
That's really weird. Can you hear me?
Still can't hear you.
I can hear. I think Matthew's microphone or speakers might be off.
Okay, because I can hear you.
Oh, that was me.
Yeah, I can hear you too.
Okay. Now that I can hear, are there any questions?
No problem. I'm rarely accused of being quiet. My question is do you have any examples of public-private partnership funding opportunities, for example, where a school district might partner with emergency management or emergency services to fund this type of project due to the mutual benefits?
Yes, there are every single day. I think there's more states coming. I think there might be about 7 states I know of right now that have grants for this type of work. They come in different formats. Sometimes they're getting like geolocated CCTV camera into the PSAP. Sometimes they're specifically indoor mapping. There's quite a few that are specifically indoor mapping. Sometimes they're around emergency action plans. So the funding is out there. It's coming. Ohio and Missouri are the most recent ones that I've seen. So yeah, there is funding out there. Sometimes it comes through the sheriff's department. Sometimes it's coming from school safety boards at the state level that push that funding. Really a range.
Great. And then I know you talked about operability or opportunities to integrate these mappings with your CAD maps. Is there a solution if your CAD is resistant or has like the interface pricing is too high, and where do you store the indoor maps if it's not in your CAD system?
Yeah, so there are a few, but not too many CAD and call handling mapping systems right now that support floor-aware data. I'm sure in 5 years the situation is going to be completely different because it is something new. And so we've been working hard to be able to get things like the 360 imagery and the floor awareness into existing providers. And really how that works is just through the ability to accept either a REST endpoint or a shapefile or a geodatabase, and some back-end work that we do to enable that. But we've been pretty successful working with really kind of try to be vendor agnostic, being able to bring that kind of data to existing products in the market.
Great, thank you. Who else has questions? Sounds like you answered them all in your presentation, Matthew.
Well, like I said, I put the information out there at the end for further questions. We're super active in the state, so much so that Jennifer reminded me that colleague Lauren's giving a presentation at the exact same time here to a different GIS specific group. And then Greg, who some of you guys might know, is also speaking around this time. So super active in the state. We're big on advocacy and education. So whatever questions you guys have, I love talking about this subject matter, and I love dreaming up new use cases. So if you think it's a challenge accepted.
Sounds great. Well, thanks so much for joining us today, and we will have this recording up on our YouTube channel for anyone who wasn't able to join us today. Maybe they're in that GIS class as well. Our next task force meeting is November 9th, so I'm looking forward to seeing you all there, and I hope you guys have a great rest of your day. Thanks so much, everybody.
Thanks, guys.
Matthew.
Thanks.
Thanks, Jim. We'll talk to you soon.
Thank you.
Bye.
Open or close?